Now, this image I grabbed from the internet to explain this particular example that I made up shows the other issue right here, which is the mean, the median, and when we get to it, the mode, which we'll talk about later. This is a skewed left distribution, and because it's skewed left, the mean gets pulled towards the tail. So in a skewed left distribution, the mean will be less than the median, substantially less, right? In a skewed right distribution, the mean will be substantially more, and if it's bell-shaped or symmetric, they should be roughly equal. Now, they're not going to be perfect, so you're going to have to make judgment calls about, is it significantly lower or just kind of lower or whatever. Okay, so for example, this from 1,000,000 to 25,000 is significantly higher, right? The mean is much higher. It's skewed right. Over here, the mean was much lower. I mean, getting a 77, 78 in a class is a totally different world than getting an 88 in a class, right? That's a full point in grade that you're missing, GPA. Or this, you might not think, 2.08 to 1. Yeah, but that is a big difference because there's a whole different world between having 2 pets and having 1 pet, as anybody with pets will tell you, right? For good and for ill. All right, so now that we've got that difference down, and we're just going to have to keep in mind that these are guidelines. They're not going to be perfect. You're going to have to do your best to try to figure out whether it's skewed left or skewed right. And he made a note, the author did down here, that this tends to work a little bit better for continuous data rather than discrete data. But we'll still have to keep an eye on it. Okay, so down here, see, and that's continuous data. It's got decimal places all over the place. These are the U.S. exports in billions of dollars to 19 countries for a recent year. The mean of this data set is 29.63 and the median is 18.3. How could you verify this? Well, I could copy, go to Excel. I'm going to grab a fresh sheet. Let me change this to, what would this be? 3.1 example 1, and then here I'll call this 3.1 example, I don't know what example I'm on, 4. There we go, example 4, just for my own benefit. Okay, let me go in here and paste. Now, name this country and exports. Okay, so if I want the mean, let me make this wider so I can see what I'm doing here. There we go. So the mean is equal to average of all this data. I'm using my mouse this time to do that. The median is equal to median of all that data. There we go. So 18.3, 29.6, just like I said they were. I'm going to put borders on that so it makes it easier to see. All right. So how could we verify this? Well, we just did. But let me type it up. So the mean would be equal to average of the data. Right now, I'm not going to bother figuring out what cells it was, which was 29.63. The median would be equal to median of the data, which was equal to 18.3. By data, I'm using shorthand to kind of say, the data cells. I think in the book I wrote, I called it data range. I wrote the Excel manual to accompany this book, so I think I called it that, but whatever, something along those lines. Okay, so use the mean and the median to guess the shape of the distribution. Okay, well, the median is much lower than the mean, right? And up here it says, hey, if your mean is substantially larger, right here, skewed right, mean substantially larger than the median. So that's what I think it is. Probably skewed right because the mean is much larger than the median. All right, let's go look at the picture. This is a histogram of this data that I drew with a program. And yep, it's skewed right, just like we thought it would be. So if that's the case, what's the best measure of central tendency? If somebody asks you what's the average would be equal to center, which would be equal to the median, because the data is skewed right. This is the better choice, as it's resistant to the skewing. I don't know if that's a word, but I'm making it a word.